Welcome to all of you. In this session, we are going to verify the circular frequency shift property of DFT using Scilab. First, let us go through the statement of it. So, circular frequency shift is also known as the multiplication by exponential in time domain. The statement is going to say that if DFT of x of n is equal to x of k, then DFT of omega n minus ln into x of n is equal to x of k minus L with respect to n. So this is a small realization of the circular frequency shift property. And finally, what we are going to prove with respect to the values is this last statement. Let's have a small example with respect to verification of circular frequency shift. So here is the representation for that. So the values are given. X of n is equal to 1010. With respect to that, we are going to validate the property. Now the first thing is we need to calculate the x of n into omega n minus ln. So we are going to make a consideration with respect to this realization. So k minus L is what the representation. L value is equal to 2. Therefore here the L value will become 2 after substituting and multiplying with the x of n given. We are going to get this representation. And with respect to left hand part of the circular frequency shift, we need to calculate DFT of this particular value, and that is what is being calculated over here, and we are going to get the answer x of k is equal to 2020. And on the right hand part of the expression, we need to identify the value that is being given over here, x of k minus 2 with respect to 4. So first we are going to calculate the DFT of this x of n, and then we are going to apply this realization so that we can get the answer for that. So you can observe at k is equal to 0, 1, 2, 3 we have substituted and we have got the corresponding answer for that, and final answer we are going to have 2020. As we can observe, this is the left hand part of the result and this is the right hand part of the result, and both of them are going to be the same. Hence the circular frequency shift property is verified. Now let us go through the Scilab program for this one. Now here is the Scilab program for circular frequency shift property. First we are going to have the sequence x of n that is being entered over here. Then we are going to calculate the length of the sequence. Then after we are going to have the input for the length for the shift operation, shift factor that is to be done, and then after we are going to calculate this exponential factor multiplied with this x of n representation. Right, that is the LHS part we are calculating. So first x of n will be multiplied with that middle factor representation, that is what the LHS part being first calculated here. Then after we are going to calculate the FFT for this shift for this part, for this L1, right. So that is going to give us the LHS part of the result. Then we are going to calculate the RHS part. So in the RHS part, whatever the first x of n sequence we are going to provide, for that FFT is being calculated, and then after we are going to calculate the x of the k minus 2 with respect to the capital letter n we are going to calculate. So for that, this is what the modulo p modulo we are going to identify. So by solving that, we are going to have the RHS part of the result. Now we are going to make a comparison of LHS and the RHS. If both of them are going to be the same, we say frequency shift property is satisfied. Otherwise, it is not satisfied. Now let us have an execution for this one. So I am going to provide the sequence 1, 0, 1, 0. The shift value I am going to provide it as 2. Now here is the solution we are going to have. So circular shift property value with respect to LHS that has been calculated is over here. With respect to RHS that has been calculated, it's over here. Then the frequency shift property is satisfied because both LHS and RHS are going to have the same values. It has been satisfied. Thanks for joining.